going to start this video out with a shot of Kitty since he's constantly trying to get into my math videos, but I want you to see what he can do. This is Abby's bedroom, and he can climb the ladder to get up into her loft, which is right up here. Go ahead, last step, buddy. Now he might be stuck. Okay, let's just keep going with the math video. All right, hopefully he's not going to interrupt us, but let me just get this in focus now. Okay, so I'm going to do the proofs that are in the cities that you have to do, because I feel like those are the questions I'm seeing from you, is that you're not quite sure how to do the proofs. So this is Fairhaven number 1, and you're supposed to prove that if a radius bisects a non-diameter chord, then it is perpendicular to that chord. So we have a chord here that's not a diameter. We have a radius, and we're going to show that it bisects it right here. All right. So let's start out with that. OD bisects, and again, he's got chord AB in there. I didn't write that, but it should be chord AB, and that's a given. Okay, step number 2 now. Is that we are going to say that segment AC is congruent to segment CB. And the reason for that is definition of bisect. All right, statement 3. He skips this one. I'm going to put it in there again. We've talked about how sometimes he writes this, sometimes he doesn't. And so just to be consistent, I'm going to write it. I'm going to say draw OA and OB. And the reason we can do that is 2 points determine a line. Again, he doesn't write that. Sometimes he does, sometimes he doesn't. So just to be consistent, we're going to write that this time. All right, step number 4 is, now that we've drawn them, we're going to say that OA and OB are congruent. And the reason is all radii are congruent. So we've got this right here and this right here. Hopefully you see where he's heading with this. Then he's going to say OC is congruent to OC. Reason, RPOC, reflexive property of congruence. A segment is congruent to itself. All right. Step number 6. Now we can say that this triangle right here and this triangle right here are congruent. So let's go with triangle ACO is congruent to triangle BCO. Reason, side, side, side. Okay, step number 7. Now that we know that they are congruent, we can say that any parts of them are congruent. So I'm going to say that these 2 angles right in here, ACO and BCO, are congruent. Reason, this is Tessa, CPCTC, cookie pie, cookie tart, cookie. All right, number 8. Now that we know that those 2 angles are congruent, right? This is where we want to say that they are right angles and then perpendicular. There are 2 different ways that we could do this. One is a long way and one is a short way. He chooses the short way, but again, remember we've had that conversation about my really fancy potato peeler that I don't use that often. You forget that it's in the back of the drawer there and you don't use it. If you remember that it's there, it's going to make the proof a lot faster. So this is one that we really do not use that often. Actually, sorry, I forgot to say one thing here. All right, first we have to say that angles ACO and BCO form a linear pair. All right, and the reason, definition of linear pair. All right, now that we know that they're a linear pair, now we can use this, where we just automatically say AB and OD are perpendicular. Let me write that a little bit better. All right, the reason, and again, this is one that we don't use that often, it says if two lines intersect and form a linear pair of congruent angles, then the lines are perpendicular. This is going to take me a while to write. If two lines intersect and form a linear pair of congruent angles, then the lines are perpendicular. And again, you don't have to use that. This is on page 169. You don't have to use that, but if you do, it saves you many, many steps. Because if we didn't do it this way, once we know that they form a linear pair, we could say that the sum of their angles is 180 degrees. Once we know that the sum of their angles, or the sum of their measures is 180 degrees, we could do a substitution because we know that angle ACO and BCO are congruent. So let me just write down some of the steps that you would do if you didn't do it this way. After step 8, we would say that the measure of angle ACO plus the measure of angle BCO equals 180 degrees. All right, and then we would say by substitution, we could say the measure of angle ACO plus the measure of angle ACO equals 180 degrees. All right, because we know that the angles are congruent already, so that we can do a substitution there. We would probably also need to put some in where, put in some here. The measure of angle ACO equals the measure of angle ACO. I'm going to skip that step, but once we can do that substitution for this into this, now we can say that 2 times the measure of angle ACO equals 180. And then we could say that the measure of angle ACO equals 90. And then once we know that that's 90, we can say that the measure of angle BCO is 90 because they're congruent. And then we can say that OD is perpendicular to AB. So again, we could do it this way with more familiar theorems, but again, if we pull out that potato peeler right there, or that potato spiraler, you're going to save quite a few steps in there. Okay, he's still stuck up there. I'm going to rescue him and end this video. Oh, there he is. This is the guy that you've been seeing all week. His shadows in your videos. All right, bye.